Welcome back. So, in previous lecture where we discussed mostly about the seismic waves and why seismic wave understanding is important for the hazard, seismic hazard in particular. So, we looked at different type of seismic waves, body wave, surface wave, and their direction of propagation and their behavior. And of course, we also discussed about the velocities and whether the seismic waves, in particular body waves, will be able to travel through different mediums and how they will behave. And also we at the end we had some discussion on the frequency of the seismic waves and their implications toward the amplification of the earth surface depending on the geology of the particular site of interest. Now there is another significant topic which we would like to you to have understanding is related to the interplate, intraplate and stable continental region earthquakes. So we practically in India we see mostly the interplate and the intraplate earthquake, and also to some extent what we the region which has been classified as stable continental regions also exist. So we have all three in total. So if you just look at the physiographic divisions of India, then what we have is broadly we can divide into three. So we have the extra peninsular area, then we have the Indo-Gangetic plains, and then we have peninsular shield area. Now before 2000 this Latur earthquake, and this area, whole area was been considered as a most stable region, but this was proven wrong after experiencing the 19 if I am not wrong, this was 1993 Latur earthquake or Kelari earthquake. So peninsular region of India, Indian plate, was considered to be seismically safe. So this whole area that what we comprise of mainly the cratonic rocks was considered to be the most safest one, excluding this portion of Kutch, because we had a couple of earthquakes in this region which were damaging, and also those earthquakes resulted into a drastic changes in geomorphology. So landscape changes was evident during those earthquakes. So with this understanding, the recent large earthquakes in this region have proven this statement wrong, and that was after magnitude 6.2 Kelari earthquake or Latur earthquake and 6.6 Koyna earthquake. Of course, the Koyna earthquake was your reservoir induced seismicity, related to the reservoir induced seismicity, but this earthquake, that is in Latur or Kelari earthquake in 1993, is considered to be because of the ongoing deformation. Apart from this event, several damaging shocks have hit this region in historical and ancient time. So when they looked at, the scientific groups looked at the historical data, then they found that this was not the only earthquake, that is the Kelari earthquake which shook the region in this area, but there were many more shocks or the earthquakes which were recorded during ancient time. And then another one was 1997 Jabalpur earthquake, which took place somewhere in this region, that is in Madhya Pradesh area, which again has alarmed that the area which was considered to be the most stable is no more to be considered as unstable, and that also was one of the reasons which was incorporated in the seismic zonation map. So with this this part which we discussed in the previous one also. So there is a correction here. This is about the Latur Kelari earthquake, 1993 instead of 1992. but rest has been filled. And again, as I told in the previous lecture also, that this map was published in 2000, so we don't have the inclusion of the earthquakes which have occurred like 2004 along this one, and we don't have the inclusion of 2005 earthquake, Muzaffarabad or Kashmir earthquake, and then two more earthquakes in this region that were above 7.5, that is in Nepal 2015. So interplate, intraplate and SCR earthquake. So if you look into the detail, it's a very simple classification that numerous earthquake occurs along the edge of the plate boundaries between the two plates, and those are termed as interplate earthquakes. So mainly such boundaries if we take, then we have mostly along the mid-oceanic spreading centers, then we have along the subduction zones, and we along the transform zones. So these are all the earthquakes which are aligned or concentrated along this type of plate boundaries are termed as interplate earthquakes. For example, earthquake associated with Himalayan seismic belt, and even you can consider this along the subduction zone, that is Sumatra Andaman subduction zone. So these are all considered to be the earthquakes which are occurring in interplate region. Earthquakes which occur within the continents or oceanic plates are termed as intraplate earthquake. So any earthquake which occurs within the plate, away from the plate boundaries, are termed as intraplate earthquakes. Now, earthquake occurring in more stable region or in the older portion of the continents, similar to what we were talking about the shield areas, the peninsular India, then those type of earthquakes are considered to be or categorized the earthquakes occurring in stable continental regions. So example is your 1993 Latur or Kelari earthquake and 2001 Bhuj earthquake. Now here for us the portion which we should emphasize upon is that the interplate and the intraplate earthquake, the recurrence interval along in this region mainly. So in case of, if you remember that we discussed about the deformation rate of deformation, the convergence rate between the Indian plate and the point in Eurasian plate, that is in Tibet, that the convergence is almost like 50 millimeter or so, and out of that 50 millimeter, hardly 5 millimeter has been consumed by the rest of the plate, whereas 20 to 21 millimeter is taken up by the collision zone, which is marked between the Indo-Gangetic plain and the Himalayas. So the recurrence interval in the intraplate case is at the order of hundreds of years, and as I have been emphasizing in a few of my lectures, that this recurrence interval in Himalaya is around 500 to 600 years or almost 700 years. Now about the SCR earthquake, they may recur only over thousands of years. So the recurrence interval is much larger, and this can be directly compared with the convergence rate, that what we are having the difference along that is along the Himalayas. We are across the Himalaya we are having around 20 to 21 millimeter, and rest of the plate is having around hardly 5 millimeter. So the recurrence increases, or recurrence is much larger as compared to what we see in the interplate earthquake, and in SCR it will be more than like thousands of years. Okay. Now due to lack of preparation to face an earthquake, damage due to such earthquake are generally very high, and this is in case SCR earthquakes, because the time interval between the two earthquakes, large magnitude earthquakes, will be more than like 1,000 years. And this I would like to emphasize here, that our studies from the Gujarat region reveal that the recurrence interval along the active fault in Kutch is more than 2,000 years. So the memory of human memory is very short, and if the earthquake is not recurred in a shorter period, then we lack in preparation, because we consider that this area is quite stable and no earthquake has been experienced or recorded from this region. So identifying potential faults and assessing seismic hazard of SCR region is very challenging task. So again, this can be at this point can be justified based on that if you are having the larger recurrence interval, so the landform which was been formed or modified because of the tectonic activity, that is what we call the rupture, may get eroded and will not be well preserved on the surface. Hence, it makes a difficult task so to identify such weak zones or the manifestation of the ongoing deformation. So, for example, it is comparatively easy to identify the tectonically active landforms in Himalayas as compared to what we do study in Kutch region, because the recurrence is so high that the features are not getting preserved on the surface because of the erosion. So, how much we know about the intraplate seismicity? In recent years, destructive earthquakes have struck some regions which were previously considered as inactive or relatively stable. So, example is not only from Gujarat or Maharashtra, but even from the areas like Canada and Australia. So, these are the two events which occurred in what we consider as unstable continental regions from India. Okay. So, Kelari, the Latur earthquake, and Bhuj earthquake with magnitude 7.6, and Kelari was 6.4. Now, the strain developed at the plate boundary is more, and very little within the plate region. So, what we had discussion that we have the, if we consider this as an Indian plate here, then along the plate boundary across this one, it was around 20 millimeter per year, and the rest of the portion which was consuming was around 5 millimeter, and that was out of the complete what we were looking at 50 millimeter per year. So, of course, out of this, half has been getting consumed by within the Indian plate portion, and rest goes with the area in the Tibetan side or China side. So, so if you just keep this in mind, that is your 5 millimeter and you have 20 millimeter, then the strain which is going to develop in this particular region, the strain will be much higher. So, higher strain along the Himalayas, whereas this region will have low strain. Now, this has direct implication with the recurrence interval. So, in the area with the higher strain will have shorter recurrence, and the areas with the low strain will have longer recurrence. So, this you can remember and this will help you in understanding that what will be the scenario of occurrence of earthquake in these two regions. So, this is Himalaya and rest of the area. So, the strain developed at the plate boundary is more and very little within the plate region, hence making the areas with relatively low seismic strain. So, this region will be a low seismic strain region, that is here the rest of the Indian plate. So, of course, we know little about the earthquake occurrence in the stable continental regions, because the recurrence is very large and the earthquake signatures which are been preserved on the surface are very meager, and that is a difficult task. Okay, but we have different methods to look at the signatures that is in the secondary effect like liquefaction and all that, and that we will discuss later on. So, we know very little about the seismicity of such regions because the recurrence interval of the intraplate SCR earthquake is very, very large. No studies of active faults, but I would say that now we can say that few studies have been carried out from this regions, mainly the SCR or intraplate region, and particularly in the area where we had 7.6 earthquake. So, very few studies have been carried out because the hazard in terms of is not alarming in very short time, hence we keep avoiding this region. So, these are the regions of less priority. So, seismic zoning, if at all done, are only based on an incomplete historical seismic records or the catalog and scare records of instrumental seismicity during last decades. So, this again was the case, and the lesson which we learned from Bhuj earthquake, that we were not at all prepared for this event as well as this event in the SCR region or the intraplate region, and that is because of the very long recurrence interval, and no active fault studies were been carried out. So, we never had a complete understanding of how the tectonic deformation will eventually result into the future earthquakes, and also the incomplete historical records in those regions. Only from Bhuj area what we had was the 2018-19 earthquake, and another was 1956. So, these were the two only earthquakes which were the damaging earthquakes from this region, what has been classified as intraplate and seismic stable continental regions. One of the causes for severe damage by earthquake in SCR region, which we discussed in the previous slide, is that very long recurrence interval, one, and then another one was that the preservation of such tectonically generated features like fault scarps and displaced landforms are very meager, because they will be eroded very fast because the time interval is very large between the two events. So, usually major earthquake in SCR region can result into a widespread damage, because the attenuation, this is another very significant reason for that, because the seismic energy in the plate interiors from such earthquake is relatively low. So, if the energy is not getting attenuated in such regions, then they will result into the more damage in the region. Therefore, even moderate earthquakes, that is moderate magnitude earthquakes, as experienced in the case of 1993 Kelari or Latur earthquake, may be extremely dangerous, and we of course we knew that more than 9,000 lives were been people got killed during the Latur earthquake, and within very moderate magnitude, and magnitude was 6.2 only. And the reason is because the attenuation of the seismic energy in this such regions by such earthquake is relatively low, so it never get attenuated very fast. So earthquake hazard and risk, usually what we consider as then earthquake hazard is anything associated with an earthquake that may affect the normal activities of the people. This includes surface faulting, ground shaking, landslide, liquefaction, tectonic deformation, and tsunamis. Tsunamis are of course, and landslides, and what we call the surface shaking, liquefaction, these are all associated secondary features or secondary phenomena which will be always experienced during the earthquake. Then earthquake risk, of course, it comes that earthquakes never kill people, but building do, and this is because of the poor construction even have maximum building damage, and people that are expected to be hurt. So the risk part will be based on that. So what will be the number of buildings which are vulnerable to the earthquake shaking, ground shaking, and how many people the population is likely to be getting affected or hurt or killed during a particular earthquake. Of course, if you talk in terms of the groups or the research groups who are talking about the geotechnical aspect, then the definition usually slightly varies, but they talk in terms of that what is the potential and the probability of earthquake at a particular given location. Okay. So, but as a geologist, if we consider, then for us this is the difference between the major difference between or the fundamental difference between the earthquake hazard and risk. But in geotechnical part, we take into consideration the source of the earthquake, and then what is the magnitude of the earthquake, expected earthquake, probability of that earthquake, that is again the recurrence interval, and the geology of the site of interest, okay, where it is located. So this all parameters will talk about the deterministic seismic hazard and probabilistic seismic hazard. We are not going to get into the detail of that about the probabilistic and the deterministic, but I'll try if I can give you some slides on that at later stage. Now, measuring earthquake, as we started with the understanding of seismic waves and in the frequency of seismic wave and interplate and intraplate earthquakes, and the high strain area, low strain area, and the recurrence interval. So the measuring earthquake is another important aspect we should know before we get into the details of the methodology of paleoseismology, how we are going to carry out and how we are going to identify the related tectonically developed landforms. Now, measuring earthquake is usually done based on the intensity, one, where the intensity is the representation of effects, ground shaking and damage of an earthquake at a particular place based on the observation of the affected area. This information is presented by isoseismal lines along with the Roman letter numbers, which is termed as intensity scale, and it can range from 1 to 12, whereas the magnitude it represents the amount of seismic energy released by an earthquake. It is measured on the basis of the arrival time of P and S wave and the largest amplitude of the seismic waves. Okay. So, other than the P and S wave, seismologist also uses the surface waves to calculate the magnitude, and the magnitudes are usually represented by the numbers, that is 1, 2, 3 and etc. on Richter magnitude, whereas the intensity has been done on the modified Mercalli scale. So this is the major difference between the intensity and the magnitude. So in earlier time, when before the invent of the instruments measuring the magnitude and the earthquake, or measuring the earthquake mainly, so the intensity was very important, and but still, even though we have the instruments installed and they are recording the earthquakes, occurrence of the earthquakes, we do the analysis, or we do we keep collecting the observations after any earthquake, that is based on the damage pattern and the deformation in that particular area, and prepare the intensity map, which are known as isoseismal maps. Now, if you go back into the history of the seismograph, so it takes you as back as almost like 2000 years ago. So the first seismograph was invented about 2000 years ago by Chinese astronomer and mathematician Chang Hing. He called this device as an earthquake weathercock. Now, this is based on very simple physics, that it is it has like total 8 dragons are mounted around the vase with the bronze ball in its mouth. So you have the dragon, and it had like 8 dragons, which are we can see only 4, and 4 are on the back side. So all these dragons, 8 dragons, are holding a bronze ball in their mouths. So whenever there was even a slight earthquake, earth tremor, okay, a mechanism inside the 8. So what you have is, one is the dragons here, 8 dragons, and respectively you have toads, okay, with open mouth, which are also aligned and sitting exactly below the open mouth of the dragon here. Okay. So even with the small tremor, a mechanism inside the seismograph would open the mouth of one dragon, and the bronze ball would fall into the open mouth of the toads. So you have this making enough noise to alert someone that earthquake had just happened. So this was even with this, even it was possible to tell that from which direction the earthquake came, that is the seismic wave came, and by seeing which dragon's mouth was empty. Okay. So this was the earthquake weathercock, which was invented way back in 2000 years ago by Chinese astronomer and mathematician. Now, if we look at the chronology, because as we discussed in one of the lecture, that with more data and what we learn from different earthquakes, we keep improving our methodology, and we keep improving the methods which help in interpretations and all that. So the intensity scale as well as the magnitude scale kept on revising based on the input of the data and whatever what lesson we learn from and respective earthquakes. Okay. So anyway, what we can do is, I'll stop here, and we'll start with the chronology of the intensity and the magnitude scales in the next lecture. Thank you so much.